Welcome to the Broadcast Dialogue Podcast, the show all about the media industry in Canada.
Today on Broadcast Dialogue, the podcast, we welcome Keith Pelletier, Vice President and General Manager of Dielectric. Dielectric has changed how FM broadcast antenna manufacturers validate directional pattern studies for new FM broadcast antennas. Dielectric's groundbreaking research resulted in the recent FCC filing of a petition for rulemaking written with leading broadcast consultancy Merrill Weiss Group and expected to be approved this fall. Keith, welcome to the podcast. First, before we start this, and we're going to get into more specifics on this, it's an FCC filing. How will this affect Canadian FM broadcasters?
David, first off, thanks for having me on. That's an excellent question. And I think the answer to that is it affects all of the broadcasters, whether we're doing business within the U.S. or Canada. Specifically with Canada, if they want to stay within a protection, this new technology that we've developed and optimized is going to allow for quicker, more accurate data that comes out of it. So for the end user in Canada, they will see a faster turnaround time using this technology and the resources that we have here at the facility. So they're going to see quicker results, more accurate results, which long term is going to lead into higher quality, more robust system, and something that they can rely on for many years to come.
Okay, let me continue here. The new rule paves the way for the first directional FM pattern verification rule change in 58 years, a rule change that passes the torch from physical to artificial intelligence-driven simulated modeling. The inspiration behind Dielectric's effort is to provide FM broadcasters with a more efficient and economical antenna modeling process. FM broadcast antenna manufacturers today build physical models and collect measured data to verify antenna patterns, a time-consuming and burdensome process. Dielectric's petition proposes that the FCC allow FM antenna manufacturers to transition to computer-based antenna modeling using computational methods, an approach widely used in other broadcast products. In fact, this technique has been used for TV station antenna modeling since 2017. So you're saying in Canada that the same procedures would apply once their governing bodies accept it. Am I correct there?
Yeah, I think you're absolutely correct. I think once this paves the way, we actually already have the process down and are able to do it today. And I'm not aware of any rules within Canada that this would not be already accepted as a current method. I think the key for the Canadian broadcasters at this point is that we've developed a process, we've developed a team, we've written rules around how to quickly get the results. So we're prepared to do that today. And in certain applications are already doing it for some specific customers.
Understood. Okay. Now, this has been used for TV since 2017 in the U.S. And the recent repack, you've done over 1,000 antenna installs. So you've used this in those applications, correct?
That's correct. In those types of applications, again, we went to computer modeling, which it's actually achieving the same things. A lot less resources on the manufacturing floor by tweaking parts, setting up models, and doing a very tedious process with multiple resources to get to the end result. So with the TV process, we have done validation that with the 1,000 antennas that we've done, and we've been able to put those in the field, get results from customers that they're very happy with the performance of our antennas. And one of the things that came out of the television repack in the United States is they're doing drone validation with an antenna on a drone. There's been over 100 drone studies validating our antenna performance is what we said it was going to be. So I think that's another feather in our cap as far as the excitement that's built up around the FM pattern studies being able to be done using AI, is that we validated our process. We've done it with 1,000 antennas. We were able to meet stringent deadlines, And now with the drone technology, it's an independent company that's now proving our antennas are working as we said. So it's very exciting times. I think, Dielectric is always on the leading edge of technology. We're always pushing the envelope in the engineering team to come up with the next best things. And we've been able to do some very exciting things. But I'm very excited. This is certainly at the top of the radar of things that we've done that's really going to help both the company succeed and also give the results the customers need at the end of the day.
Keith Pelletier is with us, Vice President and General Manager of Dielectric. And from what I understand, the accuracy is better with the AI-driven models. Am I correct there?
Yes, you're very correct, David, and that's an excellent point as well. So, I mean, there's two methods, as you stated earlier in the podcast, of achieving pattern verification today. One is a quarter scale model. And essentially what the quarter scale model means is we're doing everything at a smaller scale, so it's not a full scale test, which takes up even more resources and a larger range outside, or it's full scale modeling, which is typically done outside in a far field range. And if you can just think about the various parts and pieces and the number of measurements that you have to take, it's suspect to human error. And then once you got your final solution, you start documenting everything. You may be off slightly on some of your measurements. So what the computer modeling does is eliminates all of that. You draw the tower, you draw the FM model, you set up parametric modeling where you can adjust certain things, and you let the computer do the work. The one really fascinating part of all of this is you can start at the end. So essentially you put the customer's azimuth pattern into the program, you set up the variables, you let it run, and you walk away. And then a few hours later, or half a day later, it gives you the best results that fit what the customer needs. And looking back at doing pattern measurements, even 5 years ago or 20 years ago throughout my career, you could use a library to get you close to what the customer needs, start from there, but getting everything to fit within that protect is a very tedious process. And there's no AI to it. I mean, there's some experience built into it. So the more you do, probably the better you are to get to the end result quicker. But you could spend 2 to 3 weeks on the range for one customer, just tweaking and tweaking and tweaking before you get your results. With the AI program that we've got set up, you start at the end, you let the computer do all the work, and it tells you when it's all said and done, this is the best fitting one. So that's kind of where we're at from a customer standpoint. We've shrunk the overall time to do some of this by up to 90% in most cases. So the engineering team's very excited about setting this up. Getting more results to customers quicker, gains us bandwidth. And like I said, the accuracy that you brought up is far superior, and it's less prone for error.
Now, Keith, you talked about the engineering team. You've created kind of a new class of computers or crop of computer engineers, HFSS, computer simulation super users. Touch on that.
Yeah, absolutely. I'm glad you brought that up, David. That's a great point as well. The computer program is only as good as the users, right? So you can certainly take this program on, think you know what you're doing, and basically garbage in, garbage out. So with television repack, we have to thank for that. In starting with 1,000 antennas, we had to develop the engineering expertise within this program to really understand how to build the models, how to get results, correlate that to either results on our manufacturing floor or out in the field. So I guess the word of caution there is you really have to have an experienced staff to be able to do this and get the appropriate results out of it. And certainly with our expertise and the amount of work that we've had to do over the years, we've grown. A lot of people probably have a staff of one that's doing this stuff. Because of the volume that went through here, we probably have a half a dozen resources that know how to use this program, get fantastic results out of it, get it correlated into the real world. So it's very important to understand and have that expertise in-house to be able to make sure that we're giving the customers what they want. The last thing you want to do is not have that experience in the program, have it break down, and then the results are unknown and certainly not what the customer wants. So very proud of what this team has been able to do. They're grade A experts on designing RF broadcast equipment inside this program. So it's pretty fascinating and it's going to be fun to watch.
Artificial intelligence-based directional FM antenna pattern verification. Check it out at dielectric.com. Keith Pelletier, Vice President and General Manager of Dielectric. Thank you for joining us on Broadcast Dialogue, the podcast.
Thank you, David.
Thanks for listening to Broadcast Dialogue. For more information about the podcast or to receive exclusive access to our weekly briefing about the Canadian media industry, visit us at broadcastdialogue.com. Don't forget to like us on Facebook, connect with us on LinkedIn, and follow us on Twitter and SoundCloud.